Alright, so I'm glad that you have stuck around for the final chapter. Okay, oceans. Last study guide video, this is questions 20 to 33. Okay, a lot of questions, but we spend a lot of time on oceans, so it kind of makes sense that there's a lot of questions on it. Alright, so, sorry, and let's start off with question number 20. How much water on the planet is salt water? This should be something that is ingrained in your head. Of all the water on the planet, 97% of it is going to be salt water, which means 3% of it's fresh water. So 97%, a pretty big chunk, is going to be considered salt water. Keep that in your head, 97%. All right, question number 21. What is meant by salinity and how does salinity relate to density? So salinity is how much salt is dissolved in water. Salinity is going to vary. It's going to depend on conditions. We can expect to see, like if you think of the Dead Sea is actually very salty, extremely salty, to the point where people that are in the Dead Sea are literally floating almost on top. Now they're not above the water, but they're floating pretty close, okay, because there's so much salt. That person is so little in density, it's not even funny that it's really that high up on the water surface. So the more salt that's in the water, the denser the water is, so the water's more dense, which means anything that's floating on it is going to become less dense and float higher. If we saw, here's my examples, here's one and here's two. This is salt water and this is fresh. Alright, and we've got, let's make a red boat. We've got a red boat, this is my boat, don't laugh. And this is my other boat, don't laugh, okay? If I were in salty water, I would expect to see this boat flowing this high. If I'm in fresh water, I would actually, get myself confused. We want blue water, not red water. We would actually expect to see this boat not floating as high in the fresh water because there's not the salt that there is in salt water. We would expect to see this boat be less dense and pushing up because of the salt. Okay? All right, question number 22. What are phytoplankton and what role do they play in your life? So phytoplankton are little organisms, microscopic little organisms, okay? But they're going to be found in the ocean, and they're going to be doing some photosynthesis, which, okay, photosynthesis, we have plants, we do photosynthesis. Yes, but this photosynthesis is creating this most important thing that we all need, and that's oxygen. The world's oceans are putting out the majority of the oxygen. So yes, we've got the rainforest. Yes, we've got little trees in our backyard. This sucker right here, this ocean, this wonderful ocean with these wonderful little phytoplankton are putting out the oxygen that we need to breathe. So next time in the ocean, thank your phytoplankton. Okay? Alright, question number 23. How is ocean water temperature and dissolved oxygen related? So, the warmer the water, and we kind of hit this already with dissolved oxygen, but we'll hit it again. Alright, so question number 23 is talking about water temperature and dissolved oxygen, how the two are related. So, warmer ocean water, there's going to be less dissolved oxygen. So think about where you're chilling out when you're in the ocean, okay, and you're happy, I'm going to make you green, and you're chilling out in the ocean, you're just having a grand old time, okay? The fish are generally not going to be just hanging out with you up here. The fish are going to be down here. So keep that in your thought process, that this up here, this surface water is really warm, but as it starts getting away from the surface, the temperature is going to start declining. And you know that when you guys did your ocean floor projects, okay? We know that this is going to start declining. So as we get down here, we're going to have more oxygen. But as that temperature decreases, more oxygen, and that means this little guy right here is going to be a lot happier, okay? All right, now number 24. What is upwelling? So upwelling is bringing nutrient-rich water up. I should know this sounds really funny to say that, but it is. It's bringing that nutrients all the way down. So if we're down here, this bottom of this ocean floor, all the way down here, and this is our surface, okay, we're bringing nutrients up here. And this is why when you look at coral reefs or you look at the kelp forest or anything like that, it's teeming with life. It's very colorful. There's fish everywhere. That's because of all this nutrient action. You think about the ocean floor project you guys did. There's a lot less stuff down here than there is up here. There's a lot of stuff up here. And that's because of things like upwelling. It's bringing this nutrients up here, allowing things to live. All right, if I increase my depth, so I'm getting down here, as I go further down here, I'm going to find less and less nutrients. Okay, now we do know there are nutrients in here, but comparatively, we've got more up here. Hence why it's so pretty. Okay? All right, question number 25. So what are surface currents and what are deep currents? So surface currents are going to be caused by the winds. They're on the surface. The wind blowing, that wind action is going to cause those currents. Deep currents, the difference is deep currents are caused by density. Okay, so surface are by the winds, deeper by density. Okay, so denser water, heavier, denser water is going to sink. Less dense water is going to be up on top. Okay, and usually that is going to be based on the temperature. So if I have warmer water, it's less dense. If I've got cooler water, it's more dense. Same would apply in your house in the summertime. Okay, generally your upstairs, if you have an upstairs in your house, it's going to be warmer. The downstairs is going to be colder. Warm air rises. Okay, so that's kind of the same thought process, just apply it to water. All right, question number 26, what are tides? So literally a gravitational pull. We're talking about the sun and the moon kind of aligning and pulling, and causing the levels of the water to rise and fall. If you've been to the beach before, you know that you have high tide and low tide. Okay, high tide, a lot of the beach is going to be covered in water. At low tide, you're going to be able to go out a good distance. Okay, usually at low tide, you can go looking for shells because all the shells have been exposed. All right, question 27. What technology led to the discovery of hydrothermal vents? So any kind of modern technology, you're thinking of ROVs, which are remote operated vehicles, submersibles, any kind of small submarines. These are modern, I kind of grouped them as modern technology, but that's what found those vents. Now remember, these vents are not alive. They're part of the ocean floor. They're spewing up all this really nutrient warm water. But those vents proved that organisms could live at the bottom of the ocean without sunlight. Because prior to the discovery of these vents, scientists thought that there was nothing down there because there wasn't any sunlight. But they can get around it. Okay. All right, number 28. What does scuba allow scientists to do? So scuba is going to allow scientists, the actual scientists themselves. I don't have to be in a capsule. I can be swimming around. I can touch things. I can pick things up. I can explore up to about an hour at a time. Okay, but it's going to freely let me explore. I can only go to a certain depth. Beyond that depth, pressure is going to be an issue for me. All right, sonar, number 29. So sonar, what does it allow the scientists to do? Sonar helps us map the floor. Okay, what sonar does, the sonar is going to send down a sound wave. Beep, beep, beep. Okay, you probably hear it on like the submarines. Ping, ping. Okay, it's going to come down, and when it hits that floor, it's going to hit and it's going to bounce back up. And we can calculate this and the amount of time it takes. We can then equate it to a distance, a depth. So we know that the ocean floor isn't flat. We know the ocean floor has little mountainous areas. It's got trenches. It's got bumpiness. It's, you know, this is the ocean floor, not this. And we know that because of sonar. Okay. You also see sonar with ships that are looking for fish, large schools of fish. Pings it off, comes back, and lets them know that there's a large mass there. Okay, so they put their nets out and catch some fish that way. All right, number 30. Why would remote-controlled robots and cameras be used in deep ocean trenches? Well, we have to think a deep ocean trench isn't always going to be this very open area. It could be tight and skinny areas, jagged rocks, small spaces. So if I had a robot or a camera that's remote-controlled, I can put it in there, and I'm able to get into all these tiny little crevices without actually harming a human. Okay, and so it can get in these small areas and withstand that extreme pressure. Okay, and it doesn't have to worry about surfacing to get oxygen. It just can be down there for a while and explore. All right, question 31. What is the thermocline and which light zone is it found? So the thermocline is an area within the ocean where the temperature starts to decline fairly rapidly. It's a zone. Kind of think of it like a zone. All right, it's a temperature zone though. That tells us that the temperature all of a sudden is going down quickly. Okay, and we find this in the twilight. Okay, so the temperature is declining in the twilight. That's our thermocline. Okay. All right, question 32 is what are resources that we use the ocean for? So you guys did the little kind of exploration on the internet, looking at the different resources, the pros and the cons. So I'm not going to go through all of that, but we're going to talk about those resources. Tourism. Okay, ocean's going to provide a great place. People go there, they pay money, they go to the beaches, they utilize that. All right, obviously the downfall, pollution. Offshore oil drilling, we need oil for our cars, so they're going to drill it off of the ocean, or off the shoreline out in the ocean. Okay? Downfall is oil spills. Mining, we can mine all kinds of different minerals from the ocean, diamonds, things like that. So full of rich resources that we can use, to make things as well as to obviously make us wealthier or have more money in our pocket. Fishing, lots of fishing. And remember, we're not talking about a little fishing pole, okay? We're talking a huge netting process. But lots of people eat fish. Fish is a very popular food item, and especially delicate kinds of fishes, delicacies and stuff. So all across the world, fishing is a big thing. So fishing is something. Shipping. We're moving big things across an ocean, okay? If I want to ship 1,000 BMWs from Great Britain to the United States, it would not be smart to put one BMW on a plane per time. I could put all of those BMWs on a cargo ship and ship it across the ocean, okay? Oxygen, and we talked about that with phytoplankton, but this is obviously a resource of the ocean. It provides us oxygen, okay? All right, question 33. What is bycatch and overfishing? So bycatch is going to be the organisms that get caught up in a net by accident. They didn't know the net was there. They're swimming around with their buddies, talking about whatever, and they get caught in a net, okay? And they're not the intended catch, okay? So it might have been some tuna that was walking around doing its tuna thing. But if it didn't know that the net was there, it's going to get caught in that net, and that's considered bycatch. A lot of times these fish are going to die because they've kind of been squished and trapped in there. Sometimes turtles are in there. Overfishing is taking more fish at a higher rate than they're able to reproduce. So because we're not in the ocean chilling and seeing all the fish out there, sometimes we just keep taking and taking and taking, and they don't have enough time to keep making more of themselves. Not great that makes any sense. So overfishing is kind of basically leading a fish to extinction. That is the exciting conclusion to video number 4. If you have any questions, please do ask your teacher or go back through the video. But hope you guys had fun. I did. Hope you learned something. I certainly did. Have a good day.